Hi everyone, this video goes over simplifying radicals and some imaginary numbers in the Unit 4 packet. So your calculator can do a lot of the things that I'm going to show you today, so I'm going to give you some of the background information and then I'm going to show you how to do it on your calculator. So the first page says we're going to simplify radicals. So simplifying radicals is kind of like the idea of simplifying fractions. Like, you know that 4/8 is the same thing as 1/2. So there is another fraction that's the same thing as 4/8. If I wanted to simplify the square root of 72, there is another radical that's the same thing as the square root of 72. So what I'm going to do to figure this out, I'm going to use method 1. I'm not going to use method 2 because this is just a little background information. So what you're going to do is you're going to break the radical into the largest perfect square that goes into 72. So remember, perfect squares are like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and so on and so forth. You could like make a whole list of perfect squares. So I want to find the biggest one that goes into square root of 72. So if I'm like thinking about 72, can I divide it by like 49 and have a nice whole number? No. 72, the next one, maybe I could try 36. Oh, okay. 36 works. I get a nice whole number. 36 times 2 gives us 72. So I'm going to break down 72 into square root of 36 times the square root of 2. The square root of 36 is 6, and the square root of 2 is not a perfect square. If I tried to type in square root of 2 on my calculator, it just stays square root of 2. Like, I can't do anything with that. So I don't know what the square root of 2 is. There isn't a number that when I square it, I get 2, so I'm just going to leave that alone. So this square root of 72 is the same thing as 6 radical 2. And one way that your calculator will just simplify these for you, honestly. So if you say square root of 72 to your calculator, it'll tell you 6 radical 2. It's just giving you an equivalent format. I want to show you like one more, but again, I'm not really going to do this a whole lot just because your calculator can do it. So the square root of 75, if I'm thinking about a perfect square that goes into 75, 75 makes me think of quarters. So 3/4 make 75 cents. So that would mean 25. So 25 times 3 gives me 75. I do know that the square root of 25 is 5. 3 is not a perfect square, so I'm just going to bring that down. 5 radical 3. Now if I do it on my calculator, square root of 75, I get 5 radical 3. Notice how your calculator puts the times symbol in there, and I'm not writing the times symbol. Either one is okay, but you're more likely going to see it like this. All right, so take a minute and on your calculator, just throw the rest of these in and see what you get. If you want to confirm your answers, you can always try to break it down yourself. All right, so check your answers on here. Notice that all of them could be broken down except for number 4, square root of 30. Square root of 30 can't be broken down any farther. 1, because there's not any perfect squares that go into it. But think of square root of 30 as like 1/2. Like if someone told you to simplify 1/2, you would be like, I can't simplify it any farther. That's kind of what's happening here. It's already in its simplest form. Now, if there's no number in front of the radical, there is a 1 there, but you're not going to see the 1. So you're just going to see square root of 30. So all of these other answers have a number in front of the radical, but this one didn't. So just be aware that the 1 still exists. All right, now the next part of the unit is going to be about imaginary numbers. And imaginary numbers are basically, they're based on the fact that if you take the square root of a negative number, all right, so the next page is about imaginary numbers. And imaginary numbers are created because sometimes if you have a square root, basically a square root is telling you, like the square root of 36, for example, is telling you that the answer is 6 because 6 times 6 gives you 36. The square root of 49 is 7 because 7 times 7 is 49. Now, what happens if you try to do the square root of negative 36? Basically, square root of 36 equals 6 because 6 times 6 equals 36. Those two numbers have to be the same. But if you have the square root of negative 36, that would be like saying something times itself equals negative 36. But remember, these two things have to be exactly the same, like 6 and 6, or 7 and 7 for 49. What's the problem with having a negative? The problem is that, like to multiply, one has to be negative and one has to be positive. And if one is negative and one is positive, then they're no longer the same. So that's why when you try to type something like this into your calculator, you don't end up getting a value that works. So if I do control square and I type in negative 36, my calculator gives me an error and it says non-real result. Non-real result means that there's no answer in this mode. So we actually have to put our calculator in a different mode to be able to have it evaluate this. So to change this into the correct mode, we're going to click Settings. So we'll back out of where we were, which is option 5, and then Document Settings, which is option 2. And you see where it says real right here, real or complex? This is where you want to change it. So we're going to be starting to talk about things called imaginary numbers, which are also called complex numbers. To make our calculator able to do this, we're going to change this into where it says rectangular. Now, you don't have to know the names of these things. Your calculator will already be in this mode, so you won't have to do this ever again. But if you end up getting an error, that's where you would change it. So I'm going to hit OK. And so now if I go back to where I was and I type in square root of negative 36, it's going to tell me 6 times I. Now that is like like a cursive-y looking I right here. So 6i times 6i is the square root of negative 36. So this I that you see here isn't a variable. It's part of an imaginary number. So I is based on imaginary numbers. And really what's happening is that every single time that you have the square root under a radical, you can break it up into two pieces. The square root of negative 36 can be broken up into the square root of 36 times the square root of negative 1. We know that the square root of 36 is 6. So that's where that's coming from. The square root of negative 1, that's the most basic imaginary number that has been created, since 1 is the lowest perfect square. So the square root of negative 1 is where I is coming from. So this is where the 6i is coming from. So they are based on the fact that I is coming from the square root of negative 1. So anytime you have like square root of a negative number, you can pick your favorite negative perfect square. So square root of negative 100. You're going to take the square root of 100, you'll get 10. But since there's a negative, that square root of negative 1 is going to give you the I right there. But again, your calculator can help you out with this. So to simplify these radicals, every negative number can be written as the product of negative 1 and the number itself, the positive version of the number. So we're going to rewrite these using the fact that we can have imaginary numbers. So the square root of 25, again, I'm going to type this into my calculator, or I'm sorry, negative 25, and I have 5i. This is because the square root of 25 is 5, and the square root of negative 1 is I. That's where your calculator is coming up with the 5i. You don't have to do this every time. You can just write this. Again, your calculator will put a time symbol in between, but you can just keep them together like 5x, 5i. We did this one already. The square root of negative 36 is 6i. Now, 24 is not a perfect square. That's fine. What your calculator is going to do is it's going to simplify it, kind of like the previous page, but then also include an I in the final answer. So we've got the square root of negative 24, and we've got 2 times radical 6 times I. Now, I don't really like how your calculator displays this final answer. What I'm going to do is I'm going to take the 2 and the I, since they're both not under the radical, put them together, and then put the square root of 6 outside. The next one is a multiplication problem. So we're going to multiply 2/3, and then we're going to multiply it by the square root of negative 72. Now 72 is not a perfect square, so we're going to get some random answer like this. So we've got 4 times radical 2 times I. And again, I'm going to take the 4 and the I and put them out front, and then the radical 2 second. Now you can also do operations. Now we know that the square root of negative 25, we already did that one on our calculator, it was 5i. And the square root of negative 16, 16 is a perfect square, that's 4i. We can add i's together just like we can add x's together. So 5i plus 4i is 9i. However, your calculator can also compute this for you. So square root of 25 plus square root of negative 16 is 9i. Again, it's putting the time symbol there, but you're not going to see it. If we try the next one, 18 is not a perfect square, and neither is 50, so I'm expecting some answer that kind of looks like 3 or 4. So I have a 4 out front, and then a square root of negative 18 plus square root of negative 50. We have 17 times radical 2 times I. So again, I'm going to take the 17 and the I and put them out front, and then just bring down the radical 2. So this is called imaginary form or complex form, and this happens when there's a negative underneath the radical. That's when you get an I in your final answer. All right. So I'm going to actually skip down to the practice in the middle here. Now, your calculator can compute any combinations of whole numbers with terms that have I in them all on its own. If these were X's, your calculator wouldn't be able to do that on the regents. That mode would be turned off, but the I's it can do. That mode will be turned on. So if you needed to like add or subtract, a lot of this would be very similar to other things that we've done before. So like for 13 plus 4i plus 7 plus 5i, you're actually just combining like terms. So like 13 and 7 is 20, and then 4i and 5i is 9i. That would be it. However, your calculator can do this. 13 plus 4, and then to get the I button, oh, this is so glary. To get the I button, you're gonna have to click all the way down on the bottom where it says pi. The I, imaginary I, is in the pi like category. So you hit I from here, and you see how it's bolded and kind of cursive-y. Then you close your parentheses. Whoops, I did too many. And then plus another set of parentheses, 7 plus 5. And then there's your I again. So we've got 20 plus 9 times I. 20 plus 9 times I is what we got anyway. All right, there are some nuances to this, and we are going to talk about them next class, like when you might have to do more work than this. But if the question just has whole numbers and I's in it, these ones can be done on your calculator. So number 2, I'm just going to do these on my calculator. I'm going to type in 5 minus, and then I'm going to click pi to get to the I button. Close my parentheses, minus 2, 1 minus 3, pi, and then I. So I have 3 plus 5 times I is what the calculator says, but I'm going to just write 3 plus 5i and not include the times symbol. Your calculator can square things, 1 minus 3i, and then squared, negative 8 minus 6i. Again, your calculator says 6 times I, but we're just going to write that as 6i. And then the last one is 3 minus I, and then 4 plus 7i. So we have 19 plus 17 times I. Again, I'm not going to write the I and the 17 separate. I'll just write them together. Okay. This part down here was for the old calculator, so you don't have to use that. But so for right now, I just want you to be like okay with typing radicals into your calculator, typing radicals with negatives that will give you like I's into your calculator, and just doing simple operations on your calculator, and then we'll talk about what if we have to do them by hand.